was fluid mechanics. In the previous class, we have started with the module 1, that is fluids and their properties. So we have discussed about the concepts of fluid and also the different properties of the fluid in the previous class. So continue. We'll continue with the properties of the fluid. In the previous class, we have discussed about the uh, specific weight, specific mass, specific gravity, specific volume, adhesion, cohesion. So all the 6 properties we have discussed in the previous class. So today we'll just discuss about the next property of the fluid, that is the most important property, which is the viscosity. So here first, what is viscosity? So as you see, it is a measure of the fluid resistance of the fluid. Viscosity is nothing but, so it is a measure of fluid resistance for the flow. So here it describes the internal friction of the moving fluid. So if, for example, if the any fluid, if it is in a motion, then what happens, there will be a internal friction. So this viscosity represents that internal friction of the fluid. So coming to the definition, so it is defined as the property of the fluid, so by virtue of which fluid offers resistance to the movement of one layer over an adjacent layer. See, fluid will be made up of number of layers. So what happens when that fluid is in motion? So whatever the movement, all the layers of the fluid will be in a motion. So what happens? One layer will exhibit a resistance for the movement of other layer. So that property of the fluid is called the viscosity. So we can define the viscosity as one of the property of the fluid, so the fluid offers a resistance to the movement of one layer over an adjacent layer. So one layer will exhibit a resistance to the another layer, so that property is called the viscosity. So here the most important is the viscous force. So that is what the responsible, so that is for the moment or the viscous, for the property viscosity. So viscous force, what is viscous force means? So it is the force of resistance offered by a layer of fluid for the motion of another layers, as I told. So for example, if we consider this is a fluid, so it will be made up of number of layers. So what happens, these layers, what happens, one layer will offer resistance to the another layer, means, so the first layer will restrict the flow of another layer. Okay, so that is what the resistance of one layer over the other layer. So that force of resistance is called the viscous force. And majorly, what is the responsible parameter for this viscosity is, so basically in case of liquids, so viscosity is due to cohesion. So what is cohesion, which we have already discussed in the previous class? So it is the intermolecular force of attraction between the same molecules, that we know. Okay, so in case of liquids, the viscosity property is due to the cohesion property. So whereas in case of gases, so it is due to molecular momentum exchange between the fluid layers. Suppose this is one layer and this is another layer, so the molecular momentum exchange between these two layers will leads to the viscosity property in case of gases. And also, as the flow occurs, these effects appear as a shearing stresses between the moving fluid layers. So what happens once the flow of a fluid starts, when the fluid starts flowing, so whatever these two effects are there, that is cohesion and molecular momentum exchange, so that will leads to the formation of shearing stresses between these two layers. Okay, so that is the shear stress is responsible for the viscosity property. So here you can see in the figures, so the examples for this viscosity property. So one is water and the another one is a syrup. So compared to the syrup, water has a low viscosity because so there is the force of resistance is less in case of the water. So that's why water flow easily with a high velocity, whereas so syrup compared to water, syrup will flow slowly, and which means it has a high viscosity. The force of resistance is more in case of syrup. Similarly, if you take the water and the honey, the same thing happens. Honey will flow very slowly because it has a high viscosity, means so there is a less flow. High viscous means the flow is slow or the flow is less. So whereas low viscosity means the flow is more. Okay, so here we'll conduct the experiments. So we'll do how this viscosity will occur. So for that, what we'll do, as you see in the figure. So in this figure, so first we'll consider two layers of a liquid. Okay, so which is at a distance dy apart. Here you can see. So this is the first layer, and this is a second layer. So we'll consider the blue color indicate the second layer, red color indicate the first layer. So what we'll do, we'll consider these two layers which is at a distance dy. Okay, the distance between these two layers is dy, and the velocities of these two layers is, so both the layers velocities are different. So one layer is moving with a velocity u and another layer is moving with a velocity u plus du. So what happens, so due to the change in velocity, which is nothing but the relative velocity. Okay, so here the viscosity is basically with a relative velocity. What happens? So due to the change in velocities of two different layers, so it will lead to the formation of shear stresses. Shear stresses is, here you can see what is the difference between normal stress and shear stress. Shear stress is like a tearing stresses. Okay, so slide it will, shear means it is a slides. You can see here. Okay, so due to this viscosity and also the relative velocities of two different layers, it will lead to the formation of shear stresses. So this, whatever the shear stress which is developed between these two layers, so is proportional to the rate of change of velocity with respect to y. Because so in turn, how this shear stress is occurring due to the relative velocity, means the change in velocity. So that's why, so this relative velocity is proportion, sorry, this shear stress is proportional to the rate of change of velocity with respect to the distance y. See, this y axis represents the distance y and the x axis represents the velocity of the fluid u. Okay, so this is the velocity variation in the in case of fluid flow. So this linear curve indicates the velocity profile of the fluid particles. Okay, so this shear stress will be directly proportional to the distance. So that is rate of change of velocity with respect to distance y, and that shear stress is denoted by the symbol tau. So we'll use the shear stress symbol tau as the symbol for a shear stress. So from that definition, so this shear stress is directly proportional to the rate of change of velocity. So here du by dy represents the rate of change of velocity with respect to distance y. So tau is the shear stress. So tau is directly proportional to du by dy. So if you remove this proportionality, const proportionality, so you will get the constant of proportionality, that is mu, which is nothing but the coefficient of viscosity. So if you remove this proportionality, so you will get tau is equal to mu into du by dy, so which is nothing but the Newton's law of viscosity. So this is an equation for Newton's law of viscosity, so where mu is the coefficient of viscosity and du by dy, so as I told, it is the rate of shear strain or the velocity gradient, or the rate of change of velocity with respect to distance, which is called as the velocity gradient. Okay, so if you rearrange this equation for viscosity, you will get mu is equal to tau divided by du by dy. So from this equation, what we can define the viscosity as? So it as the shear stress. Viscosity is the shear stress required to produce a unit rate of shear strain. So unit rate of shear strain means du by dy is equal to 1. So mu is equal to tau divided by du by dy. So from this equation, so viscosity is also defined as the shear stress. Tau is the shear stress requires to produce a unit rate of shear strain. And coming to the unit of this viscosity in case of SI system, the unit for this mu is Newton second per meter square. So or Pascal second, that is 1 Pascal is equal to 1 Newton per meter square. And in case of MK system, so viscosity is the unit for viscosity is kgf second per meter square, that is 1 kgf is equal to 9.81 Newton. And similarly in CGS system, it is denoted as dyne second per centimeter square. So where 1 dyne second per centimeter square is denoted as poise. So 1 poise is equal to zero point 0.1 Newton second per meter square or 1 by 10 Newton second per meter square. So these are the units, different system of units, so which are used for viscosity for SI in case of SI, MKS and CGS systems. So next you have two different types of viscosity, that is one is dynamic viscosity and the second one is kinematic viscosity. So what is dynamic viscosity means? It is a measure of fluid resistance to flow when an external force is applied. So whatever the fluid resistance which is going to occur, so when an external force is applied, that is called dynamic. So the name dynamic indicates the force. Okay, so dynamic means we are going to consider the force. So here whatever the viscosity or fluid resistance which is going to occur when you apply certain external force, that type of viscosity is called dynamic viscosity. So mu is the dynamic viscosity, which is denoted as mu is equal to tau divided by du by dy. So whereas kinematic viscosity means it is the measure of fluid resistance to flow under weight of gravity. So due to the gravitational weight, whatever the fluid resistance, so due to the weight, gravitational weight of the fluid, so whatever the fluid resistance of the flow is going to occur, so that is called the kinematic viscosity, so which is denoted by the symbol nu. So where nu is equal to dynamic viscosity divided by density, so which is nu is equal to mu divided by rho. Rho is the density and dynamic viscosity is mu. So kinematic viscosity nu is equal to mu divided by rho. And the unit for this kinematic viscosity in case of SI system is, so it is meter square per second, and MK system also it is meter square per second. So whereas in case of CGS system it is centimeter square per second. So where 1 centimeter square per second is denoted as 1 stroke. So 1 stroke is equal to 10 power minus 4 meter square per second. So one stroke is nothing but centimeter square per second. So one stroke is equal to, if you convert it into meter square, it will be 10 power minus 4 meter square per second. So these are the units for this kinematic viscosity. Okay, meter square per second or stroke. So the next you have the Newton's law of viscosity, which is a very important topic. So in the exam they'll ask, you know, state and derive the Newton's law of viscosity. So first, what is this Newton's law of viscosity here? So as from the previous expression, that is tau is equal to mu into du by dy. So whatever the equation here, it is a tau is equal to mu into du by dy. So from this equation, so the Newton's, this is the equation for Newton's law of viscosity. So from this equation, what we can state this Newton's law of viscosity as? So it states, the Newton's law of viscosity states that is shear stress tau is on a fluid element. Whatever the shear stress on a fluid element is directly proportional to the rate of shear strain. That is tau is directly proportional to du by dy. So that is what the Newton's law of viscosity states. So where mu is the viscosity and tau is the shear stress. Stress is nothing but force by area, and du by dy is the rate of shear strain or shear deformation. So here we have an experiment to conduct to derive this expression, that is tau is equal to mu into du by dy. So we'll see what is that Newton's law of viscosity. How we have Newton have obtained this equation tau is equal to mu into du by dy. So here, according to that Newton, whatever he have observed is, first for that what he have done is, so in the figure, in the first figure you can see here, so what he have done, he have considered two plates. One is a fixed plate at the bottom and movable plate at the top. So and between these two plates, so the liquid is present. Here you can see, so he have considered a liquid between a two plates which are at a distance y. Okay, the distance between the fixed plate and the movable plate is y. So he have considered a liquid between fixed and the movable plate at a distance y, and this movable plate will be moving with the velocity u. And for the movement of this top plate or the movable plate, the force required is F. So F is the force required for the movement of this top plate, and area A is the area of contact of the movable plate. So by doing this experiment, so what he have observed is uh, whatever the force which is applied for the movement of the top plate is directly proportional to the area of the contact of that plate, that is A. So here I have observed, so F is directly proportional to A and inversely proportional to this distance y between the two plates, and directly proportional to the velocity u. Okay, so if we combine all these three, so F is directly proportional to A into U divided by Y, and if you remove the proportionality, you will get F is equal to mu into A into U divided by Y. So here, if you send this A to the left hand side, that is force by area, you will get an equation force by area is equal to mu into U divided by Y. So here force by area is nothing but the shear stress, that is tau. So tau is equal to mu into U divided by Y. So here, so this whatever the shear stress is there, so and shear stress, we have obtained an equation, that is tau is equal to mu into U by Y. So how the Newton have obtained this equation is, for that what he have done, so he have considered, so two plates, he have considered the liquid between two plates, so that is, so one is a movable plate and one is a fixed plate at the top, bottom, and movable plate at the top. So and we have considered F is the force required for the movement of the top plate, and we have observed F is directly proportional to the area of the contact of that plate A and inversely proportional to the distance and directly proportional to the velocity with which the plate is moving. Okay, so from that we have obtained tau is equal to mu into u by y. So whatever this viscosity is there, so that viscosity so will vary with respect to both temperature and pressure. So if the temperature increases, what happens? So if temperature increases, so what happens? The viscosity is going to decrease. So this is an expression for Newton's law of viscosity. So we'll just stop it here. So from in the next class, we'll just continue with the next property of the fluid.